And now we're going to jump straight into our final session with Cora Iberglide and Gabri Brody, prod-like integration testing for distributed containerized applications. Well, they will explore test containers and push the boundaries to show us how they can be used in conjunction with Cloud Native Buildpacks. Take it away.
Hello, I'm Maria Gabriella Brody. Thank you very much for being here today. I am a solution engineer at VMware, and I'm very proud to introduce my precious partner in crime, Cora Iberglide.
Thank you so much, Gabri. It is also an honor for me to be here for a second year in a row co-presenting with Gabri. It's really a pleasure to work with you, Gabri, and I'm glad that we get to do it again. So this year, let me share, I'll share my screen here so you all can see the deck. This year, we are presenting on prod-like integration testing for distributed containerized applications. Bit of a mouthful of a title. So I'm Cora Iberglide. I'm a developer advocate here at VMware. And with that, let's just get started. So what we have planned for you is a little bit of an intro into the topic that we chose for this year. It focuses around using test containers. So we're going to do a bit of a 101 on test containers, and then we'll specifically make a point about database integration testing. We'll talk about network affinity testing, having parity in your environment, and then we'll summarize it at the end. So as an intro, what do we mean by prod-like integration testing? In this case, there's all kinds of tests that you do with your applications, all kinds of unit tests, and you test your controllers and so on and so forth, entities. But what we're really focusing on here is integration testing. So where your code is going to talk to something outside of your code, right? Where your code has to interact with another system, and that's our focus. And really, the more we can have a fidelity with what we expect in production, the earlier we can do that, the better, the more problems we can find, the less surprises we'll have along the way of our CI/CD pipeline. So the more we can shift all kinds of testing left, the better off we're going to be. We're going to find problems faster. It's going to be less expensive in terms of time and any kind of resource to fix it the earlier you find it. We want developers to be able to locally on their machines iterate with the greatest fidelity. So when we talk about fidelity to production, we're talking about the type of system. So because we're talking about integration testing, we're specifically saying if you're testing against the database, you want that database to be as similar as possible to the one in production. If you're talking about network testing, you want to be able to test conditions that you would expect in a real environment, right? Not necessarily just in memory, but something that you actually might encounter in production. And then in terms of the environment, there's all these different jobs that happen along the course of a CI/CD pipeline. So every time one of those happens, what are the conditions in that environment, and are they really the same throughout the pipeline and as compared to production? So as far as integration testing, some common approaches to test against other systems. Of course, there's shared instances, right, where you simply rely on a shared, let's say a shared database, right, that your team has set up, and that's the test database. And when you run your tests, you run your tests against that, and it's someone else's responsibility to install it and maintain the hardware that runs on, and so on. And that has, it's done. It's especially whenever you think about technology, right, and think how things have changed over the decades. That was very common at a certain point. And then if you all have been around enough, you might remember installing, a lot of stuff on your machine locally. I certainly use, I have installed I remember installing Oracle XE a lot, actually locally on my machine to test against. And then in-memory solutions came around, right? H2 came about, HSQL. And testing with an in-memory database became a little bit easier. You just put a library in your POM file or in your Gradle build file, and suddenly you've got this database. It just starts up with your application, and you can test against that. So things do get easier over time, but at a cost, right? And so in-memory testing, we have in-memory testing for web servers or TCP servers like WireMock and Loki. and also H2, HSQL, very, very common and popular in-memory database servers to test against. So it's a great option, but it has some limitations. So for one thing, it requires framework support. So, we're generally, because this is Spring 1, so we're generally focused on Java and Spring. But whatever framework that you're working in, you need that framework to support an in-memory option for what you're doing, an in-memory HTTP or TCP or database or message queue or whatever it is that you want to test. And then there's behavior differences to the real system. If you're like HSQL is not exactly the same as Postgres or Oracle or something like that, right? Then there's latency and bandwidth testing. So WireMock, for example, the HTTP server does allow you to do some kind of latency testing, but it may not have the full spread of things that you might want to test, like reduced bandwidth or dropped connections. And if the product that you're working with doesn't support that easily, then it just becomes a lot more cumbersome for you to try to set up those kinds of tests, or you generally skip them at all. They become something that happens farther to the right of the pipeline. So you're going to find those problems later on if your application doesn't deal well with network glitches. And then that's only for situations where a mock server or an in-memory service actually exists for the kind of system that you're working with. They don't exist for all kinds of systems. So sometimes you're still left to start up that system externally to your application. And then there could be differences in configuration, security configuration, and other things. So this challenge, I guess what's new about it now, these problems aren't necessarily new. It's not things we haven't heard before, but the problem is exacerbated because there's been an explosion, not just because of the explosion in microservices. There are more applications that we have to manage and test, but there's also been this concept of, on one hand, using the right tool for the right job. So we work with a greater variety of service options. And there's also just an explosion in the number of available services. I mean, if you look at, for example, just on the CNCF website, some of the projects that are out there, these that you see on the screen are some of the most popular ones. But really, there's a ton of things out there, and there isn't an in-memory option for each one of these. So you might still end up having to manage it on your own. Now, the truth is that a lot of these products, as this explosion has been happening, of course, there's been other advances, like containers. And containers make it pretty easy to stand these up, right? Just Docker run and test against that. That's not so bad. Or if you need to stand up many of them, you can do a Docker compose and start up several things at once. And it works. And Docker Compose and Docker Run are both great because it'll work for any framework, right? You're not just limited to, in the in-memory case, as what can run in memory in your application. But this can still be cumbersome. It still generally requires, configuring it separately outside of your application. You might have to pick up additional skills. If you don't know Docker Compose, then you have to spend the time to do that. It's outside of your kind of bread and butter. So it's still a little cumbersome, and everything that's a little bit cumbersome for one thing that you're doing becomes, it becomes infinitely more cumbersome as you scale. So good news, there is an easier solution, and so that is what we want to talk about today, which is Testcontainers. And so as you can see in this image, Testcontainers, it is a dependency that you would add to your application. But then that dependency takes care of doing that, what would be that Docker run for you, right? And a few more other things. It's a little fancier than just the Docker run. But basically, it runs within your app, so you get the convenience of the experience of running something like H2, for example. But in effect, you're actually starting up a container on Docker. So you get the variety of the things that you could do with a Docker run or a Docker compose. So kind of the best of both worlds in that sense. So let's get to a Testcontainers 101. So it's a Java library, as I mentioned, or at least Testcontainers Java is a Java library, and it creates instances of Docker containers that you can use for testing. It's pretty straightforward. It supports JUnit 4. It was pretty tightly coupled with JUnit 4 rules, but it also supports JUnit 5 with JUnit 5 extensions, and it also supports Spock. So Testcontainers Java is the one you see here on the upper left-hand side. That project, if you look at the code on GitHub, you can see, I think it's about 5 years old. And a couple of others of these also have files that date back to 5 years, 3 years. So if you do go to the testcontainers.org website or their GitHub site, you can see maybe 5 to 10 languages that are supported at different levels of maturity, but there are options for other frameworks. So this isn't purely for Java, but we are highlighting the Java. It started with Java. Java is the original implementation. And it's, I think, probably maybe the most mature, but others there are a few others that have been around and have you can see the usage stats on GitHub to assume that they are equally reliable. And so if you, on the Testcontainers website, you can also see what kind of modules they have out of the box. So there's a bunch of modules you can see in that middle rectangle. You can see that they do support Docker Compose. So if you just have a Docker Compose YAML file, they could start everything that's declared in there. And then very common things like Kafka, Nginx, Rabbit, et cetera, HashiCorp, Vault, et cetera. And then within the databases category, you can expand that and see all the different kinds of databases. So it's not quite the spread that, from the slide where everything was jumping out at us from the CNCF, but it's a lot. And on top of this, really anything that you can start as a Docker container, Testcontainers can start it. So you're in no way limited just to this list. If you have a Dockerfile of your own, then Testcontainers can use that. So why use them and where do you use them? So as we said, the reason is because you want your integration testing to be as similar to production as possible. So you want the system that you're testing with to be as similar to prod. And in order to really do that, we need an easy way to do that, right? If things are too hard, you have to make the right thing to do the easy thing to do. So this helps do that. It helps make testing against actual systems that look like your prod easy. So easier instantiation of these disposable services when an in-memory option is not available, and you can test against any application that can run as a container. And you're trying to do that integration testing, right? The data access layer or your application integration, or they actually support sort of the Selenium browser-based, so you can do browser-based acceptance testing and test against your application. So just a little history on Testcontainers is that the inspiration for them came from this gist written by Moshe Eshel. The gist is 7 years ago, and you can see that already 5 years ago, there's a comment lower down on the gist that says superseded by testcontainers.org. So, but this is where the idea started. And you can see that what Moshe had written was a Docker container rule for JUnit 4 to start up a Docker container from within an integration test. So that's still the essence of what Testcontainers is. So I'm going to show you here some syntax from JUnit 5, but it also works for JUnit 4. So basically in JUnit 5, there's a concept called a JUnit extension. And so you can see here on the upper declaration, Testcontainers extension implements, and then you can see these callbacks before each test, before all of the tests in a class, before, after each or after all of them, then the actual test, and then the post processor. So it's an extension that intercepts all of these stages of the life cycle of a JUnit test. It's the same with JUnit 4. I'm just showing here from the JUnit 5 integration. And so with JUnit 5, that actually gets declared at the top level of the class with an @testcontainers annotation. But that's the implementation in the background. And then within the class, within your test class, when you want to create a container, with JUnit 5, you use the @container annotation. With JUnit 4, you would use @rule, @class_rule. But either way, this basically, so in JUnit 5, this is telling the test containers that this is one of the containers that you have to manage. So if one of these JUnit lifecycle events happens, then you have to kick in and either start the container or stop the container. But Testcontainers is basically managing that lifecycle and helping you, of course, connect to the container that it's starting. So if you leave it the way it is, then it'll be one container per test, and you can declare them. You can also declare them as static so that they can be reused as any static object would. So let me show you a demo of all of that in action over here. So we've got some tests, Java and test container basics. So I want to illustrate some of this that we've been talking about, the life cycle, because it really works in conjunction with JUnit. So this is a really simple test where I've enabled test containers, and it's using JUnit 5. You can see Jupyter is the name for JUnit 5. And we're creating a container. It's just a generic container, nothing specific, not a specific one of those, you know, databases or modules that we saw in a previous slide, just something that we're creating. And I'm using this, an image. I'll show you. Let me come back to this for the next one, but just, you know, just some container that we're getting off the internet. And essentially, here's the constructor for this class. So we just have a statement just to say, hey, I'm in the constructor, because what we want to do in this test is track the life cycle of JUnit and see what is it that Testcontainers does at every stage of the JUnit lifecycle. So we're just going to put a log statement in each one of these methods. So we have the constructor of the class. We have before all of these tests are run, before this class is created, an instance is created. What happens after all of it's run also, what happens at the end. We're going to have two tests, so we can see this cycle through twice. And then we have our before each test method and our after each test method. And that's it. It's just a logging statement. So let me go ahead and run that. And we'll see what is happening. And what I can do also on this screen is maybe do zoom. Watch Docker. Okay, so you can see, so my Docker images was empty at the beginning. So it's already downloaded this thing called Testcontainers Riak. And this is just an image that is used to clean up after, to like shut down the other Docker containers that it's going to start. So that's the first thing it does. And you can see here in the log file, it's pulling an image, right? Because I started with a clean Docker images, Docker daemon. So it has to pull this image that we're going to start, this one called, the one that we declared as our container, right? Our container is going to be a container starting from this HTTP bin image, so it had to go pull it from Docker Hub. So after it pulled it, my two tests have run. So let's look at the logging in particular. So we're looking for these hashes that are there for us to easily see it. So you can see that the first thing it does is it calls this static method before all, and the only thing that's happening there is the thing that we printed. So Testcontainers is not adding anything to the before all. And then it goes into the constructor of the class. So it's getting ready to run our test number 1. So it creates an instance of the test class. So this instance, you can maybe make a mental note. This ends in 477. And so this is the first time it's kicking in. So Testcontainers first says, hey, is Docker okay? Is Docker installed? Is it up and running? Let's check on that. So it does check on Docker. And then it says, okay, well, what container do you want me to start? So it's this HTTP bin image that we've declared in another file. This is okay, I don't have that on the local Docker daemon, so let me pull it down. First it pulls down Riak, which is its own internal cleanup image, and then it pulls down HTTP bin. And then it finally creates the container for our first test. And so then it moves on to the test. And so the test consists basically of the before, the test, and the after for that test. So in the before, we're just printing out here the instance number of the class. Again, mental note, that was a 477. And it's created a container for us, a container ID, and then AF2. And then it runs the test, and then it does whatever we had declared in after. You can see it's not really adding anything except our log statement. So Testcontainers is not doing anything in these methods. And then after our test number 1 finishes running, then it removes the container. So now we know that if we have 2 tests in a class, it's creating, it's going to use a different container instance for each of those tests. So now on to test number 2, it goes back in, recreates creates a new instance of this test class. So we're back in the constructor. So our 72 now is now it's 391. So, and then you can see that in this constructor, it does a lot less, right? In the first constructor, it downloaded React, it downloaded the image, it checked on if Docker was okay, all of that's done. So all it does is it finds the local, on our Docker daemon, it finds the local copy of our HTTP bin image, and it just starts up a new container. So then it goes into the test, which is the before, the test, and the after. So you see here the new IDs, our new class ID, our new container ID. And then at the end of that, it cleans it up. So that's it. And then the static, after all, it doesn't do anything. So that is how test containers ties in with the life cycle of a JUnit test. So that's a solid understanding of, like, what it's doing when. So okay, so what we've seen so far is that it creates a new container instance for each test that we're running. But what if we don't want to do that? Because it's kind of a waste of time in some cases. You can run faster tests if you don't have to restart your container between each test. And if you're not doing if your tests are not affecting the system in a way that you can't recover from, then there's no need to do that, right? Like, so if you're doing a database test, maybe you just truncate that database table, and so you can start cleaning for the next test. So as long as you're in control and you know that you're cleaning your anything that you've done well for the next test to have a reliable starting place, then there's no reason you shouldn't use the same container for multiple tests. So you can do that by simply adding the word static in front of your container. So if we run this one, we can compare the logs. And so here we see, I'll go look at the top level of it. So here again, so it's starting, so it says, is Docker okay? It doesn't have to do all the polls, right? React is already pulled, the HTTP bin is already pulled, so it simply just says, okay, let me start an instance. And then it does the first test, which is, it goes into the constructor, so we have our B09 instance, and then it goes and it does the before and the test and the after for our one test. And then it goes into the constructor for the second one. It does create another instance of the constructor, right? The first was B09, so it creates a new instance of the class, B2, but it does not start a new container because that instance that we started was static, so it's being reused by this second constructor instance. So, so we've saved that little bit of time, and then at the end, it removes the container. So that's what making it static does. The next one I want to show you is a connection test. So now, okay, so what is this HTTP bin image? Let me show you. So the type of object is a Docker image name from Testcontainers, but basically it's just a way to reliably parse this image name. So this is an image that actually comes from, let me show you this. There's a website that I love to test against. It makes things really easy, httpbin.org. And it's just a website where you can send requests and, anything you want. Like, so we can go into our dynamic data. For example, if I call the UUID endpoint here, we can try it out, execute. So if you send a request to httpbin.org/UUID, it returns a UUID, something like that. So it's really easy to test against. And so this is, on the internet, but you can actually Docker pull this container and then just do a Docker run on your own machine, and you can have this utility locally. So what we're doing is just borrowing from Kenneth Reitz. Thank you very much, Kenneth. This great little utility here. And so that's what we're doing. We're just saying pull this down literally and start that up. So in our connectivity test, so as you saw here, actually, if you noticed, here we're being told that if you do pull this down, it's going to listen on port 80 internally. So you want to map some port on your local machine to port 80 on the container. This, this can be anything you want, but internally this is listening on port 80. So we want to make sure that we map something to port 80 that we can use to connect to this. So here we're telling test containers, hey, pull this down, but also expose port 80. we're not saying 80, we're just saying the second 80, because we know that this is listening on 80, and we're going to let test containers map this for us. So let's go ahead and run this test. So here we've got two tests. The first one is going to send a request for that UUID endpoint I just showed you, and it's going to send it to localhost :80. So, so based on what I just said, we would expect this to fail, right? Because even though 80 is the port that the HTTP bin is listening on internally, that's not the port that Testcontainers is going to use to map to that. So in fact, we do see the one with a fixed URL has failed because port 80 is not exposed on our machine, connection refused, right? The second one we're using instead of hard coding that URL as we're doing here, instead of hard coding the URL as we're doing here, we're actually getting it dynamically. We're doing the host as well. In this case, it is localhost, but always has to be a host and container dot, and just go ahead and get the first mapped port. Usually you use the first port, so there's just a sort of a shortcut method. Get the first mapped port, and you can see that in this case with a dynamic URL, it's pulled out 55069 was the port that it dynamically mapped to 80 inside of HTTP bin, and in this case, it does work. It succeeded, right? So then the next one I want to show you is that, as I mentioned, it doesn't have to be a container. It can be a Dockerfile. And so here in this directory, in this temp directory, I've actually downloaded an application. This one I'm also borrowing from Testcontainers. They themselves have a Hello World application that they use for their own internal testing. And it has a Dockerfile, simple Dockerfile here. It uses the Golang image to build the app. It uses the Alpine for runtime. And so let's go ahead and run that one. So now we're saying, now create a generic container, right? Because this is no longer not an existing module. And we could just say, just create it and then throw it away after. But actually, we want it to keep it on our Docker daemon. So we're going to tell it, hey, why don't you give it this name, Testcontainers Hello World, and don't delete it when we're done with the test. Just leave it on our Docker daemon. And so it's going to pull up this source. So I also have this here, which is the path to this code is temp hello world, which is exactly what you see here, temp hello world. So I'm just saying, go into this directory, and that's where the Docker file is, and that's also where the source code is. So that's why it's a dot here, because once you get to that directory, that's also the build path as well as the location of the Docker file. And then just not using all of these things necessarily, but just to show you, you can add build arguments, you can add runtime environment, you can expose more than one port, you can tell it to wait for something to make sure that the container is ready, all of these different things. And then we're just going to go ahead and call, again, two endpoints. So let me go ahead and execute that. So we're going to do one test from the first port here and another test from the second port here. And just here it's building, so maybe we could watch. It's still watching. Watch that. So we'll see. It'll just take a second, but it should download. It's going to have to download the Golang. Oh, there we go. So it's downloaded the Golang image. So it's doing the build, that first part of the Docker file. We should see the Alpine image show up in a few moments. There's the Alpine image. So now it's creating the runtime image. Oh, there it is. So it's created our container image, and because we set that variable delete on exit to false, it'll keep this one here. So future tests would be faster because we would already have built it. And then it starts it up and it runs our two tests, right? Just two endpoints that we know that are in there. So that's how you can use any Docker file that you want. And then I wanted to show you, so far we've been starting containers, but we don't know what if their container throws an error, what kind of logging is happening inside the container. So we can also get logs from the containers. There's a couple of ways to do that. So here, and here's another kind of way to start a container. You can actually just, here we're just using the base Alpine image. So now we're just going to use we're just going to go ahead and just use this image, which was the base runtime image that was used for Hello World, but just sort of like an empty kind of like a plain OS kind of image. So we're going to run that. And instead of putting an app on it, we're going to declare what is the command that we want to start when that container is created, when an instance of a container is created from that image. And we just wanted to do 2 lines of echoing. One of them is saying, starting up with some environment variable and the value of that, which we're also creating here. We're saying set greeting to hello world. And when you start up, print starting up with greeting equals, that value. And then print another line, oops, something went wrong, and then print that to the standard error output instead of the standard out. So we're printing a success message and we're printing an error message from this container. And so we're going to get the logging for that. So let's see how to do that. Let me run this first. Okay, so in this first method, we're gonna get the container logs using container get logs. Very convenient. And what this does is it basically dumps out all of the logging that's happened on that container up to this point in time, since the container started. You can do all of the logging, or you can just get the standard out, or just get the standard error. And then we're just running an assertion here that says, consider this test successful if an environment variable called greeting in the image equals hello world. So we're also showing that you can set these environment variables within your image in this way. So test 1, get logging as a string. Let's see that. Go down to where the logs are. Okay, so here it is. Our container logs all, has our line of success and our line of failure. And then when we get only the standard out, we just get starting up. And when we get only standard error, we get only the oops, something went wrong. In the second example, we want to stream the logs. So that's also possible. You start the container. So here we're also, another thing I should point out, in both of these, because this container is not annotated with that container, right? So we're not telling Testcontainers, hey, make sure you lifecycle manage this container. It's not doing that. So we're lifecycling it on our own, at least the start. It'll shut it down manually. So in both of these, we start the container. And then after the container is started, we can actually say follow the output using this log consumer, which we're just giving it the same one that this class uses. This is created by this is Spring Boot test, so that log is automatically created, so we just pass it, and we're just going to follow that output. So in the second example, we see that happening where here it is, it's right in line, and it's using that the log consumer associated with our demo 5 container logs test logger that was created by Spring Boot. And so those both lines, and you can see that this one is info and this one is error. So these are coming from different streams because we said with separate output streams. So we got all of that logging. And of course, this log is created, as I mentioned, by the Spring Boot test, right? So those are all those demos I want to show you. I'm going to show you one more, which is, now, let me just show you one slide here. So that's really the 101 on test containers. Now, just to dive in on one of those points, if you're doing database testing, one of the reasons that you want to use test containers is because you can get closer to the real system, right? So for example, if you're testing against Postgres, you can use H2 or HSQL, and it's close. There's a lot of testing that's very valid. You probably want to do a lot of your unit, a lot of your, lower testing, your repository testing, or against H2, but you really want to do your integration testing against something that has a greater affinity to the actual Postgres. So that's really the impetus behind this. So I'm going to show you one more example. Okay, so here we have an integration test that uses H2, really simple. You can see all of the properties are here. And the most interesting thing here is it's using Flyway to execute the SQL, to create the schema, to modify the schema as it changes over time. But you can see here that we are using H2. And it's even here, the H2 is being told, behave like Postgres. Be as Postgres-like as you can. And the SQL that we want to run, so you can see it's coming from Flyway, we're telling it to look in 2 locations. So the first one is just the original create statement for this resource database So first it just creates a sequence for Hibernate, and then it just creates a table called messages, pretty straightforward, 3 columns. But then we want to do a migration, and for whatever reason, we put this script over here. Our migration says, this is the important line, put some data in there, and then I'll add a column for date of expiration. So yeah, so basically we have a table where folks can put messages, but then we don't know when to delete the messages. So we decide later that we want to add a column that's called date of expiration with a timestamp of date, so that we can know when to delete the messages. And then we want to, for all of the rows that were already in the database that don't have a date of expiration, we want to insert a date of expiration so the column's not empty. So we're going to do that with this update messages, set this new column called date of expiration to the current date plus 1 month. So we'll give these messages a month to live before we delete them. So let me go ahead and run that. So remember, so this is running this SQL against H2, and it fails. And it fails because H2 doesn't like this syntax. So you could say, well, that doesn't work. But the truth is that it would work against Postgres. So here's just a place where H2 syntax and Postgres syntax are not aligned, even when we've told H2 to be as Postgres-like as possible, right? And we've also set the dialect to Postgres. So, so we can use Testcontainers instead. So now we're going to run, it's exactly the same code, except we're going to say, start up a container of type Postgres. And here's another cool thing. Start up this container, and as we know already, since we saw in a previous test, it'll auto-generate some of the connection information, right? So the host and the password, the username, all that stuff should be auto-generated. But for Spring, we actually want these properties, these Spring properties, to have those values. Our data source, URL, username, password, and the database platform. All right, actually the URL, username, and password, we want these to populate these 3. So we can't get them from our properties files because we don't know what values Testcontainers is going to generate. But we can get this object, this container object, and say, get the JDBC URL, get the username, get the password dynamically. This was kind of like when we did the get first mapped port. This is the equivalent for a database, except we're putting it into, using this dynamic property source, we can populate these Spring, and this is a Spring Framework utility, right? So this is Spring Boot giving us a way to auto-populate these Spring properties, dynamic property source. So otherwise, this is the same as the other one. So I'm going to go ahead and run this. And our expectation here is that the SQL, the interval syntax is okay, actually. It wasn't ever really a problem for Postgres. So we're expecting this to succeed. So it's pulling down that Postgres image so that it can test against a real Postgres. We see, I should show up here in a minute. And there's Postgres, it downloaded it. Now it's going to start it, and it's going to run our test. And it says that everything, in fact, is fine. We didn't write that SQL, so we're good. And I think the last thing I'm going to turn over to Gabby, but is that as you see, if you use a combination of all of this, even though Postgres is a module that's distributed by Testcontainers, but you can actually, you can have your own generic container and use your own preferred flavor. So if you're using, for example, a Bitnami Postgres, right, which is a container that doesn't allow root access, so it's a little bit maybe closer to what you'd have in production again. It's easy enough to configure it with a generic container and make sure you're setting the properties properly. Pretty straightforward, but you can do the same test with your more specific choice of database. So I need to give this to Gabby so that she also has enough time for her part. So I'm going to sign off. Thanks, Gabby. Go on to you.
Here we go. Let's talk a little bit of network reliability. Well, we know that when we run in our application across a network, actually there are many other things that can happen despite of errors or misbehave of the application, of the code itself. But it's really the network that is interconnecting all these applications that can raise some type of issues. We can have more latency than the one that we were expecting, or a decrease in bandwidth that can be for many, many reasons. There can be connections that are unexpectedly closed because there was a problem with one of the steps in the network, like the router, or simply because someone unplugged a cable, or I don't know, something happened directly to the process. But also there can be changes in packet size. Let's think about different, like when your packet, when your communication traverse different network, you can go from environment that are using the standard packet size of 1500 bytes for an Ethernet packet to the jumbo Ethernet, where it's actually 9K. So, of course, having this type of changes is going to have an impact at the end of the day on the bandwidth, again, because there is going to be all the overhead that we need to account if we need to send more packet over to transfer the same amount of information. And so because of all these reasons, it can happen that actually our application works, but it doesn't work when there is a network in the middle, and everything goes bananas. But there is a good news. We can use ToxiProxy, here the really, really nice logo that I love, that is a framework that is specifically has been designed specifically for testing. And it's interesting because it gives us a number of nice knobs to tune exactly all of those parameters. So we can inject random behavior, we can do chaos testing, or we can emulate something really specific that's happening in the network between our connection. And the nice thing of ToxiProxy is that we can use it to test HTTP, TCP, UDP connection, where more of the time when you work like a test, like a framework like WireMock, it's gonna only use, you can only use it to test HTTP connection. So it gives really a lot of freedom. And ToxiProxy and Testcontainer are actually working together because ToxiProxy is still, of course, available as its own component, as its own application, but it also works as a container that is actually delivered as a module from by Testcontainer. It will be started as a separate container, and this container, this ToxiProxy, it's going to act as the proxy for all the traffic. So you want to put ToxiProxy in between the component where you want to emulate some type of specific behavior. The requirement is that ToxiProxies and the services that we need to test need to be on the same network. Now, when we were we were working with Cora, and she was showing how we can expose port, but there is a difference between the port that has been exposed by the service itself and the one that we can expose on the host. The one that will be exposed on the host by Testcontainer is something that it's gonna happen randomly to avoid any type of conflict. For this reason, we can benefit from a definition of a construct that is the network construct. The network defines exactly a network between ToxiProxy and the containers that are running the services that we want to test. we can only have one network associated to each container. So this is going to be like the limitation that we need to think about. But we can have multiple containers that are sharing the same network. Let's take a look on how this is going to work. So I'm going to open, and I hope that the font is big enough. So we have over here, everything that Cora was talking about is still, of course, true over here. The application that we are going to test is an application that has a Postgres database in the back. And what we want to do is that, first of all, we are going to create our network, as we were saying. So now, when we start our Postgres database, we can actually start this database with inside that network. And in that network, it's going to expose this port. So now we know that on this network, this is the port that this Postgres it's going to work on. Very nice. As we move forward, then we can run the Toxi proxy, and we run Toxi proxy as one of the modules directly from Testcontainers. Again, we assign the same network over here. We can also assign alias to easily name our services on the network. At this point, what we want to do is that we want to get this proxy and say, look, you are going to be a proxy for this port for the database. Perfect. So now let's build the URL for our database. That's going to be based on the parameters for, sorry, I have the Zoom control, for the parameters from Toxi proxy, so that we are going to take IP and the port through that. And what we are going to do then is I'm going to run a first test message, a first test to retrieve messages where I don't want to do anything bad. Then there is a second one where I'm going to add latency. So I'm going to be sure that I'm adding some toxic aspect to this communication. And specifically, I'm going to say that the latency is going to be 1 second of latency downstream. And I also have a third test where I'm going to cut the connection. So let's see what happens when we run this test. So at this point in all of this, when we are connecting when we are trying to connect with the Postgres database, in reality, we are going to go through the proxy that is going to inject this latency and eventually also cut the connection. So let's run this test. And we can see how there was something while the test ran. Because there is a connection pool that is already open, I'm adding over here a delay, because I want to have a totally new connection to work on. Otherwise, I'm going to hit a network timeout that's going to be the standard network timeout that's going to be pretty long. And for this reason, I am right now making this small change over here. Now, you can see that the message, the one that didn't have any type of changes in the network, was working fine. The second one, also the second message, the second test has passed. You can see that it's green, but the third one failed. And it failed because the connection, it recognized that at some point the connection wasn't existing anymore, was closed. And this test fails. So we know that at this point, we should do something if we want to treat this specific situation. We want to deal with this. We can add the circuit breaker in our code and like apply all the standard strategies that we should apply in this case. Let's talk now about environment affinity. When we think about environment affinity, and specifically now, let's go back to the code side of this conversation. To achieve parity in test, in build, and in run environment, we need to be sure that we have exactly the same object, the same artifact that we are working with. So in terms of operative system that we are using, in terms of runtime, all the intermediate layer, and often enough, because of the type of approach that we are using, this is not really possible. And or it's not that it's not really possible, but can be really challenging. And this is because if we are using, for example, a pipeline where we have different stages in the pipeline to build, to run, to do our test, we need to be sure that we are maintaining all of these, all of the configuration parameter, all the base images, all the version of the code to be the same at every step. And this is really hard to be kept synchronized. We can use another approach that is the one of the two stages Dockerfile. And in this case, we have more control because at this point we know that the build and like the run, we have control on top of which are the images, the operative source, like the from statement is the one that gives us control on the different layers. But it's still hard to manage when we are running at scale. Luckily enough, there is a better way to do this, that is through Cloud Native Buildpack. This project provides a way to consistently build our images at scale. It delivers a builder through an image. And so just by using that image, that builder, we know that we have easy control on what we are going to build, how it's going to be built. And it's easy to maintain at scale. It's polyglot. And another great thing is that there are many different ways to consume this. We can use CLI. There are Maven and Gradle plugin. It can be used on Kubernetes. So now when we look at our initial pipeline, we can see how, okay, we achieve this type of control. By default, when we run, and right now for the specific purpose of this conversation, I'm going to focus on the Pack CLI. And the Pack CLI is going to use the Maven Buildpack. And by default, the Maven Buildpack, it's going to skip the test. That's not exactly what we want. We want to do the test. Let's see which are the challenges in this case. Well, very nice. We know that we can use a command like this, where we can use Pack to build our application, provide the builder image. Oh, sorry, guys. Provide the builder image for our builder, and then define which are, in this case, I'm saying, look, I want to run a test, specifically run this test. And that is the Toxi proxy test that we were looking at before. But wait a moment. We said that all of this is distributed as an image. That means that test and build will be run by the builder inside a Docker image. This means that when our Maven is going to do the package and wants to start Testcontainer and wants to do all this nice thing, there is a problem, because to do this now we need to have access to our Docker, and for security reason, Buildpack don't allow high privileges for to maintain to ensure security. So this is a guardrail that we have. So we know that the moment the builder run, the privileges are dropped. So now what can we do? Well, a way to go around this is to get access to the host through a different way. Specifically, we are looking to talk with the host using TCP instead of the unit socket. The unit socket will require elevated privileges to be accessed. But if we go to TCP, then we can still achieve this, still being safely respecting the guardrails that the Cloud Native Buildpack is defining. So now, how can we do this? Well, we are using a common utility that's called the socket, is socket cat. It's available across different operating systems, and there are a number of alternatives to this specific one that you can find. The thing is, let's run first of all a socket to provide a channel that runs on the spot that we are defining. And essentially what it does is that streams the true point of the connection between the socket, the unit socket, and whoever is going to connect to this port. And so at this point, we can provide our information to Docker host using this specific syntax. Let's check how this is achieved. So I'm going to go really, really quickly to this. And here is our small script that we run back to do the build and then run a socket to give access to our to the Buildpack, and then specifically execute toxic proxy test for our application. Now, because we know that this test it's going to fail, I think it's better to ignore this test for now. Perfect. So now let's go over our terminal and let's run this. I'm going to give localhost, and I already ran this pack command before. You can see that it's starting the container with pack. So a lot of the components that are used are already downloaded. So for this reason, it's going to go pretty fast. We can see that over here there is the plugin that we want to use, specifically, the builder that we want to use. And we can see that now we have control, for example, on Java version and in general on everything that has been packaged in the builder. So now our tests are running. And actually, this not often doesn't refresh. So let me restart. Dannazione. Yes, I close it up. 1 second, let's do this. Localhost. Okay. And let's see how this it's going to run the test, and at this point also produce finally the image that we want to use. And everything happens during the build phase. And I hope that I still have a few minutes. I think that our Zoom, it's a little bit interfering over here. I don't know why. Let me see if I can do this and restart. Yeah, no, I'm sorry. It's can I rerun just the last time? I just want to see. Sometimes when I type wrong information. And hopefully, the third time is a charm. Otherwise, we will go back to this. Okay, yes, eventually I type localhost as I usually do with some mistake in it. Very sorry about that. As you can see now, Testcontainers is started, Proxy started, Postgres is started, and so all of the SQL has been executed to do migration in the database, to add a line to the database, and now, okay, let's now go quickly to the next step. Takeaway. Well, Testcontainer can help in doing this test with a more affinity with what is going to be the final environment. Proxy is a really great tool to do tests for network resiliency. And with Cloud Native Buildpack, we can actually use a tool that gives us control on top of all the aspects of the image that we are producing. And all of this runs on your local machine. So fail fast and keep calm. Here are some links, and thank you very much to whoever was able to stay up to this point. Thank you.
Thank you all. We're going to see you, Gabby and I are going to hop over to Slack for the next 15 minutes. So join us if you have questions.
Cora and Gabri, what an incredible presentation. Thank you for sharing your time and expertise. This knowledge equips us to be able to carry out more prod-like integration testing earlier in the development lifecycle. If you have any questions for Cora and Gabri, please click the Slack link in the Now Playing tile on this webpage. And from the Slack channel, you can find a Zoom link to this presentation's Q&A session. And that's a wrap for Spring 1. Thank you for taking valuable time out of your week to learn and play with us. And just a reminder that the recordings of all of the sessions will be available on the Spring 1 website starting on September 7th. Goodbye.